Lesson 3-4 deals with parallel and perpendicular lines. So right now, go ahead and take some time and fill out the review portion dealing with transversals and the word transitive, talking about the transitive property that we're going to talk about today with parallel and perpendicular lines. All right, we're going to start our lesson today with Theorem 3.7 and Theorem 3.8. Theorem 3.7 is the transitive property of parallel lines. And then Theorem 3.8 deals with two lines are perpendicular to the same line, then those lines are parallel. So let's go ahead and go through those. Theorem 3.7 states if two lines are parallel to the same line, then they are parallel to each other. This is known as the transitive property of parallel lines. Theorem 3.8 states that in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So 8. Let's start with the Theorem 3.7. If A is parallel to B and B is parallel to C, then A is parallel to C. It's a transitive property that we knew for congruence, that we knew for equality. The transitive property just holds for all things in geometry. In a plane, if two lines are perpendicular, so if M is perpendicular to T, the little upside down T symbol, that means perpendicular, and N is perpendicular to T, then obviously M is parallel to N. So symbols are important, and the two symbols we're learning today are the two lines side by side means parallel, and the upside down T means perpendicular. So how can we solve a problem with parallel lines? Looking at the three pieces at the right, we want to know if we can form, that'd be four pieces at the right. We want to know if we can form a picture frame with the opposite sides parallel. So we're going to circle the correct phrase, complete the sentence. To make a picture frame, you will glue two different angles together. If you glue the same angle together, it will not work. The angles at each connecting end measure 60 degrees and 30 degrees. And when we glue the pieces together, 30 degrees plus 60 degrees equals 90 degrees. Everybody make sense? All right, so we're going to continue working on this problem on the next slide. So the top and bottom pieces will be perpendicular. The left piece will be parallel to the right piece. The top piece will be parallel to the bottom piece, and both opposite sides are parallel. And I put perpendicular. That is a mistake. I don't like mistakes. No harm, no foul. We just fix it. Opposite sides are parallel. So underline the correct words to complete the sentence. Yes, I can assemble the pieces to form a picture frame with opposite sides parallel. All right, now we're going to look at perpendicular transversal theorem. In a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. It's common sense. If you have two parallel lines, there's a line perpendicular going through it, transversal perpendicular going through it, it's going to be perpendicular on both lines. So place a right angle symbol in the diagram at the right to illustrate 3.9. I've got so much better with these little things. So we want a right angle symbol. Let's see if I can do this. And there we go. There's where your right angle symbol belongs. All right. Use the information in each diagram to complete each statement. Line A is parallel with line G, and A is perpendicular to T. So therefore, G is perpendicular to T also. In addition, C is perpendicular to line N, that's what we're given, and line N is parallel to line P, so C is also perpendicular to P. If you have any questions about the perpendicular transversal theorem, make sure you jot them down. But basically, if two lines are parallel, they're cut by a transversal that is perpendicular, it is perpendicular to both lines. So we can prove a relationship between two lines using this information we just learned. We're going to look at the diagram at the right, and in a plane, that's all in a plane, line C is perpendicular to line B is perpendicular to line D, and line D is perpendicular to line A. Can we conclude that A is parallel to B? So let's go through our little exercises to get to our explanation. All right, we're going to circle the lines that are perpendicular to A. Now, we're only going by the information given in drawing. We're not going to assume anything at this point. So, the lines that are perpendicular to A is just D, because that's the only thing we're given that's perpendicular to A. Now, we're going to underline the lines that are perpendicular to B. There are two lines that are shown to be perpendicular to B. That's C and D. So, lines that are perpendicular to the same line are parallel. Therefore, we can conclude that A is parallel to B because line D is perpendicular to both lines. Okay, and also we can say A is parallel to B. Common sense tells us that since C is perpendicular to B, it is also perpendicular to A. So that's our lesson for the day. I want you to go through now and look at your lesson check. So it was an easy lesson tonight. Go through and answer the problem about Avenue A and Avenue B. And then go through and which theorem or postulate from earlier in the chapter supports the conclusion in Theorem 3.8 in the perpendicular transversal theorem explained. So I want you to go through and answer those two questions. We'll go over them tomorrow when you come into class. Or if for some reason we get to this lesson today in class, so that's yesterday or today before you look at this tonight, it's like that logic class. If yesterday was, never mind. So we'll either do this today in class or you have a video to watch this evening and come back in tomorrow ready to start on 3-4. Have a good evening and good night.